Welcome back, and thank you for joining us in the SDEC Symposium, Tightening Biosecurity. My name is Montse Torremorey, and I'm a faculty member at the University of Minnesota with the Swine group, and I will be chairing this part of the symposium. To get started again, we have with us Dr. Kate Dion from the Hanor Company, who will be talking about a few of the things that herself and her team have learned about when they investigate first outbreaks associated to construction events. Dr. Dion is a graduate from Iowa State University, DBM, and then at the Hanor Company, she is a veterinarian and also animal well-being quality assurance manager. She's also working currently, she's pursuing her master's degree at Iowa State University. With that, Dr. Dion, thank you.
Hello, everyone. My name is Kate Dion. I'm a veterinarian with the Hanor Company. And first off, I would like to thank Montse and the Layman Conference Committee for inviting me to speak on this topic today. And what I'm going to be talking about is PRRS breaks associated with construction events. And so what I hope to do today is really go through a series of cases, 3 in fact, and describe the events that occurred with those outbreaks that we determined to be associated with a construction event causing the outbreak, and then provide some recommendations and lessons, that we've learned from those, and how we're going to move forward to try and, stop those construction events from being such a risk for us in the future on our farms. And so, first I want to step back and, say, how do we determine that a construction event was the cause of the break on a farm? And so when we have a PRRS break, what we do to try and figure out what the event was that caused the break is to use an investigation team that uses the SHIC Rapid Response Outbreak Investigation Form. And what we do is use a minimum of at least 2-person team to investigate the outbreak. And the main investigator, we always try to choose someone that doesn't have direct responsibility for that farm on a day-to-day basis. So, maybe someone that's a veterinarian in our system, but is not the main veterinarian for that farm, might be someone that, doesn't quite have the biases, that's going to deal with that farm on a day-to-day basis. We use an investigation period that is 1 month prior to the onset of clinical signs, so that hopefully we can capture the event or series of events that led to that outbreak. And then after we've completed the investigation, we go through the various events that occurred and we categorize them as either a low, medium, or high for the likelihood of being responsible for that PRRS introduction. And so really, what we expect is that we're probably not going to actually find the main cause of the outbreak, but construction and maintenance events actually seem to be kind of the exception in my experience with doing outbreak investigations. And I think it's just because that, they are big one-time risk events where you can kind of, associate some of the things that occurred with them, just because there's a lot of moving parts. And sometimes, there are outside people coming onto your farm. So there's just a lot of biosecurity steps that, have the potential to not be done correctly, and, risks and carrying agents that don't get mitigated like you would hope. And so overall for Hanor, when we're doing an outbreak investigation, what our goal is we're trying to identify areas where we can improve biosecurity and hopefully reduce the frequency of disease outbreaks in the future for both the farm that we're doing the investigation on, as well as the Hanor system. And what I would say is that when we're doing an outbreak investigation, we always learn something. We may not find that one smoking gun cause of the outbreak, but we definitely always have some things that we learn and some pieces that we can use to educate and try to get better at biosecurity. So starting with our first case that I'm going to review, it really turned into a series of unfortunate events. And so in October of 2019, right at the beginning of the month, unfortunately on a 10,000 head sow farm, we had a fire. Luckily, it was contained to just one farrowing barn. The doors that were connected to this very barn were thankfully all closed like they were supposed to be, and they helped stop the fire from spreading. But, the reality is at this point, we've lost 25% of our farrowing capacity on this 10,000 head sow farm. So really at that point, the race is on, right? We've got to build, and reconstruct this farrowing barn, because we don't have any extra farrowing space in a nearby farm where we can move animals, to help deal with this fire. And so at that point, what we have to do is we drop the wean age on this 10,000 head sow farm, which is less than ideal for us for both the reproductive results we hope to achieve, and definitely trying to hit our wean to finish performance goals with dealing with a young wean age. So as you can imagine at this point, from the fire, going forward, there's just a huge amount of activity going on this farm, and a lot of people visiting this farm, both from an internal and an external standpoint. And so when we did the outbreak investigation, we made it to mid-January of 2020, and we started seeing some abortions in gestation barn 9 on that farm. And so, in that month investigation period, we had 37 events of non-handler workers on the premise related to construction. So as you can imagine, in a 30-day period, we've got more than one event of people entering the premise per day. So just, again, a lot of activity, a lot of people on that farm that were not our actual internal employees, as well as, the increase in the number of internal maintenance staff that were working near the affected barns, right? It's all hands on deck at this point to get this project done, and done quickly, so, we can get back to normal on this farm. When we looked into the processes, for the procedures for the people working on the outside of the farm, they didn't use any shoe covers or a process for disinfection of boots prior to working on the site. As well as, we just really had a lot of vehicles, tractors, skid loaders, a backhoe, on the site that wouldn't normally be there. But what we did find was that if they were a non-handler vehicle, they were actually disinfected off-site by our handler maintenance staff prior to coming on the premise. So hopefully, any risk from those vehicles would have been mitigated. And another event that, was big during this 30-day period prior to the break was that we had 3 large shipping containers with equipment delivered to the farm. And so when we investigated, we found that they were not disinfected prior to entry to the premise. And they were entered onto the premise and then unloaded just outside of gestation barn 9, which again, remember, is where we see the first clinical signs. The materials in the shipping containers themselves were eventually disinfected, but realized, that we pulled out a lot of equipment, a lot of cardboard, a lot of plastic right outside of that gestation barn. And so then the question really becomes, how did the virus then enter the farm, right? In theory, we didn't have any of the construction crews and the maintenance crews inside the farm. They were limited to the outside of the farm. The interior of the farm was blocked off from where they were working. But the reality is it's just a lot of people, a lot of moving parts. So it's entirely possible that, maybe they had come into at least the dirty side of the farm entry to talk to someone on the farm. And, for sure, at that point could have had some cross traffic with our on-farm employees entering the farm. And for sure, with so much activity going on the outside of the farm, there was just a huge amount of cross traffic with the farm employees, whether that be in the parking lot prior to entry into the farm, or when those farm staff were performing outside tasks like checking on bins or, removing mortality from the outside of the barn, as well as, staff that would be associated with that farm, right? Feed truck drivers, just again, a lot of cross traffic that occurred. So, at that point, a potential carrying agent for how the virus could have entered the farm could have been contamination of employees' shoes into the farm office. And then if their farm entry procedures were not 100% in compliance with what needs to be done, then maybe they tracked out in the farm. Or the fact that we had, all of this equipment unloaded just outside of the barn 8, maybe there was a breach somehow that occurred there, since, that's a where we first saw those clinical signs, and just a lot of activity occurred on the outside of that barn area. So moving on to case 2, that occurred this past summer on a farm that we actually detected PRRS during weekly surveillance tests on processing fluids. And at that point, we really didn't have any clinical signs in the breeding herd. And so this one was, a really frustrating case for us, just because this is a relatively new farm for us in the system. It, is really, from a facility standpoint, well set up to have good biosecurity, as well as a farm manager and farm staff that were really diligent about the practices. So, going into the outbreak investigation, we were already kind of questioning, like, are we really going to find anything that is going to be related to why this outbreak occurred? And so in this case, when we went and looked at the sequence, it was quite different from anything that we had in our HANOR sequence database. And so we went back and asked the MSHA folks to run this sequence through their database, and they found that a similar virus was found within 50 to 100 miles of the farm in the last 2 years, and within 150 miles of the farm within the last month. So at this point, we at least know that this virus is in our region, in our area. So, definitely some concern for, whether it be, outside, construction or equipment that may have connections to another farm in our area. And so when we did the outbreak investigation, the major construction event that we found that we think was related to this outbreak was that there was a pit discharge line break that occurred outside of barn 7. And this was underneath the barn on the very west end of the barn. And so 10 days prior to those positive processing fluids being found, our HANOR internal maintenance crew dug the line up to determine what was going on there. And that same day, they had an internal plumbing crew come to take the measurements for a replacement pipe. So, obviously in this situation, the job was big enough that needed specialized labor to come in and do this repair. So, we needed to have an outside crew as well do this. And so, moving closer to the break, 6 days prior to those positive processing fluids, again, that external plumber returned to install the new pipe. We found that biosecurity had been discussed with this plumber, but one thing that didn't occur was they didn't actually sign off on our visitor and vendor acknowledgement form. We found that their vehicle did enter the premise and it had been washed as been requested, but as far as the actual plumber working around the site, they didn't have any shoe covers that they used or boot disinfection, as they worked on that farm. But we did find that the equipment and the tools that they used to actually do that repair were from our internal maintenance shop. So, at this point, you can see that, we have an external plumber on the outside of the farm, their vehicle, and this new pipe, but didn't actually bring any outside tools or equipment in to make this repair. And so again, how did this virus enter? Well, this plumber didn't actually enter the inside of the farm. So, the potential probably occurs just based on the location of this barn that they would have had some cross traffic, again, with the farm employees performing the outside tasks. So, that is one possibility. The other possibility is definitely, since they were working with our internal maintenance to make this repair, they had cross traffic with our employees, their vehicles, and then also potentially could have cross-contaminated our own maintenance shop area, since they were in there to get the tools and equipment they used to make this repair. So again, a potential carrying agent could have been the contamination of the employee's shoes in the farm office, or a breach that have occurred on the outside door of barn 7. Because interestingly, even though we really didn't have clinical signs to help us identify where the start of the outbreak was, those first positive processing fluid samples were from barn 7, where that repair was being done. And so, maybe someone stepped out to talk to him, or he opened the door to talk to someone on the inside. So maybe a breach occurred at the outside door there. As I said, we always learn something when we do these outbreak investigations, and we did have an incidental finding there that we did have one maintenance employee who did not follow the correct downtime for entering the farm during the investigation period. They had actually visited a nursery prior to visiting the sow farm, didn't have the correct downtime. And so, what we determined was that although this was a breach in procedure, this was unlikely to be the source of the virus, as this nursery was being monitored for PRRS and was testing negative. But it is a good reminder that mistakes do happen, and we need to make sure that both the maintenance staff understand the correct procedures for downtime, but also be empowering our farm managers to make sure that this is occurring, so that any potential risks due to downtime aren't occurring. So then moving on to case 3, this one occurred in December of 2019 on a farm where we saw in gestation barn 305, sows were off feed, and then that followed very shortly with abortions. And so when we looked at the sequence on this farm, we found that it was actually 100% similar to a farm that was 16.5 miles away. So this particular farm where the PRRS outbreak was occurring really is situated where it's not located next to any other farms. There are none within 5 miles, but somehow, we've brought something in from a farm that's 16.5 miles away. That farm is actually a handler farm. So at this point, as we're going into this outbreak investigation, we are looking for operational connections to this sow farm of ours that's also positive for this virus. And as you can imagine, with it being within the system, we're going to find likely multiple operational connections to this farm. And so then we really have to focus in on, which of those connections actually had, some sort of event where, a mitigation step wasn't followed and had the potential for, the virus to actually enter the farm. And so when we went through this outbreak investigation, we found that the week prior to the outbreak, we had our internal handler maintenance crew on farm for a variety of projects. They were there for the entire week, doing a lot of welding, and there was a section of a barn that had to have its water trough liner repaired. And so the farm manager was on vacation this week. It was also a holiday week. It was over Thanksgiving. And so, as you can imagine, things, just maybe weren't quite as normal on that farm as they would be during a non-holiday week. When we talked to the assistant manager who was there on farm that week, she thought that the maintenance crew was following biosecurity with, how they enter the farm, how they enter their tools and supplies. But what she did say is, she didn't have anyone that was always watching them. And like I did say, we did have a water trough repair that occurred. And so, those are very large pieces of stainless steel metal trough liner. And so on that particular farm, they were too large to fit through that farm's disinfection room. And so that farm has a vehicle disinfection station at the farm entry. So the maintenance crew used that to spray off that metal trough to get it disinfected. So, the hope was at least the metal trough itself, had a mitigation step. But the interesting thing was that clinical signs with those off-feed sows occurred in the exact same location as the trough repair. So there was something related to that trough repair that we needed to key in on as the source of that virus. So again, we ask ourselves, what is the source of the virus? And, especially in this case, what is the operational connection to that other positive farm for how that virus then was moved to this farm in question? And how is that related to that trough liner repair? So as we work through the procedures for our maintenance staff, They meet every Monday morning at our maintenance shop and then get their, various assignments for the week, and they split off and go to their farm assignments. And so on this particular farm, we found that, they entered the farm premise, they did their disinfection steps with that trough liner at the vehicle disinfection station. And then they proceeded to go park their vehicle very close, right outside the barn door of that gestation barn 305. And this allowed them to have their tools right next to the barn there so that they could grab them. And so after they parked their vehicle, they went to the farm entry and did their shower-in procedure. But when we asked them about the disinfection process for those tools that they were bringing in, we didn't get a good answer. So, it was listed as being unknown. So it's possible that, those were taken directly off the truck into the farm. And so in this situation, I think what likely occurred is either that vehicle was still contaminated with that virus, or those tools or supplies that they were pulling off their truck were contaminated from the other farm and brought the virus in. While there was downtime, at least over the weekend from that farm, is it possible that at that maintenance meeting that, someone grabbed a tool off of a truck that had been at that other farm inadvertently and put it on this truck, and then if it didn't get, disinfected, we inadvertently brought that virus in. It seems like, that this is, the reason why we walked this virus right directly into this farm, exactly in the place where we were doing the repairs, even though the trough liner itself had disinfection. So overall, what I would say when doing these outbreak investigations and tying the source of the virus to a construction event is there's a couple of things that can be really useful in making that determination. And the first is that a sequence may be important. It can help you determine if there's operational connections to other positive farms to establish that link, or to a location if you have an outside crew coming in. The actual location and the clinical signs on the farm may be indicative of a construction event. And, this is the reason why I say that, sometimes these construction events are the ones that we actually feel more confident that we found the event that occurred, because when you have clinical signs start in the area where your construction or your maintenance is performed, it really does strengthen the story that could be the source of the outbreak. And so overall, what did we learn? What are the recommendations? What are the take-home lessons that, these various cases, related construction events can teach us to help us better our system and hopefully improve our biosecurity related to these events in the future? Well, the first, is if we can avoid construction projects during the peak of the PRRS season, try to really schedule that, preventative maintenance stuff in the warm weather. That can at least try to stack the odds in our favor of when the virus is less likely to spread just due to having, hot temperatures on our side. But the reality is this isn't always feasible, and emergencies do happen. So you do still have to be prepared to do these type of events, even in cold weather, when viruses are able to spread more readily. So the things that then we need to focus on is we really need to establish and continue discussing biosecurity requirements with construction and maintenance crews. And first off is really to have that good discussion at the beginning of the project to make sure that expectations are understood, understand downtime, understand supply equipment, entry procedures. And, really for us, we want to make sure that we have those, especially outside crews and visitors sign our visitor, vendor, and biosecurity acknowledgement form. What that does is, not only through that discussion, lays out exactly what needs to be done, it's written down, but really it helps formalize that process and, gives them a copy so that they can, understand it and just really hopefully be able to hold them accountable a little bit more, just because, you're signing on the dotted line there. But I think the other thing with us especially is, since some of these construction or maintenance projects can be long-term, we really need to kind of continue and repeat questioning of that crew, regarding their downtime and contact with other pig premises or equipment, because when these things are ongoing, we see that you have people switching in and out on their crews. They might be here 1 week, but then over the weekend we switch out to other people, and those people might have been connected to another pig farm the week prior, and just their job really is to focus on making those repairs or getting that construction done. And so biosecurity might not be at the forefront of their minds. So we just need to continue talking about it, so we can make sure that everybody's on the same page with what has to happen, and then have the opportunities to have those discussions about, things that are difficult to get on farm and disinfect and what we're going to do there. The next thing that I think is really important is if we have seen in multiple of these cases where we've got outside work going on, and in theory, people not actually entering the actual farm buildings, we need to try and establish that outside line of separation from construction personnel and their vehicles from our own on-farm employees. So the first, is to try to minimize any vehicles coming close or next to the barns. So with that, would not only help mitigate the risk of that actual vehicle being the source of infection, but also would limit that temptation to go out and, just go grab a tool or a piece of equipment off your truck because it's close to the barn. The second thing I think that, is we need to establish some sort of shoe cover, a shoe change, or a boot disinfection process for people working on the premises near the barns. This would help mitigate any risk that their actual shoes or the inside of their vehicle poses. And so one way that this can be done is actually using a storage container for those construction workers, similar to what we would ask a truck driver entering a trailer to use, where they use that tote that has their clean shoe covers or boots on the inside, and using that lid or that container to actually be a secure area for them to actually make that boot or shoe cover change. And then, the other thing I think is just having those discussions and laying out those boundaries of, hey, here's where we need you to go, and here's where we need you to avoid, just so you can limit that cross traffic with on-farm staff parking and then their entry back into the farm. Another thing that is just really challenging with these type of events is trying to figure out a way to get downtime or disinfection for all the supplies and tools that enter. This can definitely be challenging just based on the nature of those type of either large equipment, large supplies that need to be brought in, and just their difficulty to disinfect. So sometimes downtime can be utilized to help mitigate that risk instead. But overall, I would say, avoid directly delivering those equipment initially close to your barns. And with that, I would try to have a disinfection step before they actually come onto the premise and after, just so you can cover yourself on both ends. But alternatively, one thing you can do is to have those tools available on farm for those construction or maintenance staff to use, so then they don't actually have to bring anything in, and then that disinfection step is not necessary. The challenge with that is sometimes the equipment is very specialized and expensive and not used frequently, so you may not want to put that kind of investment into it. But the other thing I would say is, if you are making those investments, make sure that you're getting good quality tools that they want to use, because if it's not good quality and it's more difficult for them to use on farm, then they're just going to be tempted to go and grab their equipment off of their vehicle, where you may not have that good disinfection step. The other thing I think, as you can see, is, especially in some of these events where we really aren't positive that the outside crew enter the farm, is we have to remind our farm employees during these projects that there's a really high risk of cross traffic, and at that point they may be the person that's contaminated with the virus. And so we have to make sure that their entry procedures are just ironclad, right? Getting that bench entry and the shower procedures 100% of the time, completed correctly is going to be so critical during these events. And this would be a good time, to, if we're not already doing it, actually add in another mitigation step of even having our employees put shoe covers on as they exit their vehicles into the farm, just so we can have another layer of biosecurity, because the likelihood of cross traffic, it's just real when you have these type of events going on. And then again, especially focus on, when we know those cross traffic events are occurring, and especially doing any sort of outside task on the farm, we, hopefully could, make sure that we can move those types of tasks to the very last thing of the day, actually after the farm staff have showered out, so that they're not going to re-enter the barn to help mitigate that the most. But if they are going to have to re-enter, again, we have to make sure their entry procedures are just ironclad so that they aren't the source of the virus. And the last thing that, one thing that I've thought about is it might be valuable to actually have someone on farm just overseeing these construction and maintenance crews when big projects are being done, make sure that they're actually complying. It seems like that might be a lot of time, but that time compared to the cost of an outbreak, actually might be money well spent. And so overall, really just thank you for the opportunity to present these cases today. And I hope that, some of these lessons are applicable to others in trying to improve biosecurity related to construction events. And so I'll be happy to entertain any questions in the chat, or you can contact me directly after this presentation. Thank you.
Thank you very much, Dr. Dayon. Very interesting presentation, and thank you for sharing some of the things you are learning as part of those investigations. So we will move to the next presentation. The next presentation is by Dr. Donna Dreves from Seaboard Foods. Dr. Dreves is from a graduate from the University of Minnesota, and she joined Seaboard Foods, and it's part of the veterinary team. Her presentation will shift the focus to investigating infection in growing pigs and what we can learn from those infections from a biosecurity point of view. Donna, thank you.
Good morning. Today we're going to go through the presentation, Investing PED Infections and Lessons to Improve Biosecurity in Finishing Pigs. To briefly outline the presentation today, I will begin by giving you an introduction of the Seaboard Foods system, review how PED has behaved in the Seaboard Food system, walk you through why we decided to attempt PED elimination in the finishers, discuss the steps in PED elimination in the finisher, and finally talk about the implications of this process. For those of you who are unfamiliar with the Seaboard Food system, we are the third largest pork producer in the U.S., with live ops in Oklahoma, Kansas, Colorado, Texas, and Iowa. We are a vertically integrated company that currently has approximately 330,000 head of sows in production. This means we market roughly 7 million head per year, and I am one of 6 vets that oversees the health of the system. So to begin, the Seaboard system was part of a large PED outbreak when it was introduced into the U.S. herd in 2013. The graph on the right shows breeding herd incidence for the Seaboard system since 2013. The incidence percentage is on the y-axis, while the year is on the x-axis. 62 sow farms are included in this analysis. As you can appreciate, there has been a significant decrease in incidence since 2013. Improvements in biosecurity, such as bakers being installed for commercial flows, regionalization of flows, and cleanliness of farms were key to this decrease. Today, sporadic breaks still occur at the sow farm level, with an unclear method of introduction in most cases. Even with the significant decrease in sow farm and nursery PED break incidence, we did not know what was occurring in the commercial finishing population. We assumed it was endemic and had evidence of infection with limited clinical signs. However, we did not know this for a fact and began monitoring to better understand regional prevalence and incidence at the commercial finisher level. Two key aspects of our system include all of our finisher pigs are greater than 10 weeks of age at transfer into the finisher, and we have no wean to finish sites. Findings of initial monitoring were not surprising. The picture on this slide represents our monitoring area. PED positive sites are indicated in red or orange, while PED negative sites are indicated in green. PED was present in the commercial finishing system in western Kansas and the Oklahoma/Texas panhandles. We had PED negative sites right next to PED positive sites. In addition, some of the PED positive sites sat in very close proximity to PED negative sow farms and nursery sites in the Texas and Oklahoma panhandles. Monitoring was initiated with the objectives of understanding PED prevalence, when PED infections occurred, and the risk factors for PED infection in the commercial finishing population. By understanding those aspects, we wanted to be able to decrease the risk of PED breaks in all phases of production across the system. Remember, in a system, PED negative status does not stop at the sow farms or nursery sites. So, after making the decision to better understand PED in the finishers, an action plan had to be compiled. Our steps in this plan were: first, determine the PED site status for all finishers. Secondly, determine when known negative PED sites were rebreaking relative to the turn. And finally, determine action items to prevent the rebreaking of known negative PED sites. The first step in this elimination process was to determine the status for all commercial finishing sites. We initiated a rolling 3-part testing scheme to accomplish this. Part 1 was pre-ship testing. This will be referred to as PST moving forward. 1 oral fluid per barn was collected 1 week before the site started to ship. Part 2 was post-placement testing, referred to as PL moving forward. 1 composite Swiffer was collected 1 week after the site filled. Part 3 was clinical signs, referred to as CS moving forward, which was 1 composite Swiffer collected anytime a scour was seen on site. All samples were tested via triplex PDT PCR at the ISU VDL in Ames, Iowa. PCR results were interpreted nightly by a staff veterinarian. Anything with a CT below 30 was considered positive. Anything with a CT equal to or above 30 was considered non-infectious genetic material. As long as no clinical sites were present on sites with CTs equal to or above 30, we considered the site negative. It should be noted that a cutoff of 30 was based on prior experience with PCR testing in growing pigs and discussions with diagnosticians. After interpreting the results, sites were assigned to 1 of 3 previously established health statuses. Stable sites were PED original, PED indel, and porcine delta coronavirus negative. Line 2A sites were porcine delta coronavirus or PED indel positive, while line 2B sites were PED original positive. We made the differentiation between line 2A and line 2B based on the clinical impact at the sow farm level. In our experience, both porcine delta coronavirus and PED indel are less severe than PED original. Site status was communicated daily to field personnel through the biosecurity positioning list and weekly via maps. Staff and equipment moved from stable, which is shown in green, to line 2A, shown in orange, to line 2B, shown in red. So the testing scheme was initiated week 42 of 2019 in all commercial finishing regions. I compiled the data and reached out to the University of Minnesota Swine Group, week 20 of 2020, to help answer some more in-depth questions. The three main questions I presented to the UMN swine group were the number of sites in a geographical area that had never been PED negative, the number of times PED was introduced into a given site, and the time frame of introduction relative to the turn in weeks. For the purpose of analysis, an introduction was defined as any time a farm moved from stable to line 2A or line 2B. Sample type responsible for turning the site positive, and time in weeks between the last negative / first positive was analyzed. So this slide uses farm 203 as an example of how the data was analyzed. On week 38, the site tested PDT negative via pre-ship testing. On week 40, the site was PDT negative via post-placement testing. And then on week 48, the site turned PED original positive via clinical signs. So in this example, the sample type responsible for turning the site positive was clinical signs, and the time in weeks between the last negative and first positive was 8 weeks. So moving on to the actual analysis, we wanted to know the number of sites in a geographical area that had never been PED negative. We found one site that had remained on line 2A/2B during the entire 30-week monitoring period. This site was up in northwestern Kansas. Our next question was the number of times PED was introduced into a given site/geographical area. In this chart, the geographical area is on the y-axis, while the number of introduction into these areas is on the x-axis. It is important to note that there were farms with multiple introductions. Overall, the virus was introduced 123 times into 117 sites. Upon completion of analysis, we could really dig into the different risk by area. So Kansas Northwest was a high-risk area with 64 introductions into 102 farms. This is a 62% chance of introduction per farm. The Oklahoma Panhandle was a low-risk area with 8 introductions into 41 farms. This is a 20% chance of introduction per farm. This is important because Kansas Northwest is an 800,000 head finishing complex that shares multiple resources. We will discuss the importance of this in greater detail later in the presentation. Our final question was the time frame of introduction relative to the turn. In this chart, the first column is the type of introduction. To quickly review, PST is pre-ship testing, PL is post-placement testing, and CS is clinical signs testing. The sample type listed first is responsible for the last negative, while the sample type listed second is responsible for the first positive. So one category, negative post-placement to positive clinical signs, accounted for 57.36% of the introductions. Mean time of this introduction was 8.81 weeks post-placed. So this showed us we were successfully cleaning up sites prior to placement of a new group of animals. However, we were tracking the agent back into these clean sites. So upon completion of analysis, we were able to state the following facts. First, there was a greater proportion of introductions that occurred in a geographical area with a large finishing complex that shares multiple resources. Second, the most common method of introduction was negative post-placement to positive clinical signs, 8 to 9 weeks in phase. We concluded that our PED site cleanups were successful. However, PD was being tracked back into those clean sites via contaminated fomites. Some examples include personnel and shared tools. So our largest action item from this was designing a more rigid traffic flow and investing into additional multi-site and site-specific equipment, such as tools and site-specific sort boards for loadout crews. Another conclusion from this study was that sites were breaking, recovering, and then PD was being tracked in further along in the turn. It is important to note that up until this point, if a site was moved down to line 2A/2B, it remained on that level until it was eligible for one of the 3 testing parts. We implemented retesting sites 8 weeks post-introduction. Most of these retested sites were eligible for stable status. By adding this 4th part, we decreased the risk of a site recovering from an introduction and then having a second introduction due to being grouped with the contaminated farms. So overall, we have made significant strides in decreasing the PD pressure across the system as visually shown on these maps. Once again, red is line 2B, while green is stable. So currently, we are on 100% PD negative in all commercial finishing sites across the system. So this shows it is possible to drastically decrease PD pressure in a system. Another important takeaway was introductions without clinical signs is possible. There were multiple sites that tested positive without ever showing clinical signs during this monitoring period. This shows that a robust monitoring scheme is essential if you want to truly establish current finisher health status. Moving forward, we will continue with an aggressive monitoring plan that includes all aspects of the system. This includes farms, feed mills, truck washes, and the processing plant. This is an ongoing process. We will need to see what happens when the high-risk season begins again. There are multiple unknown questions at this point, such as how many breaks at all levels of the system will we see with the lower number of PED positive sites? And will the high-risk time period be the same or change given the change in testing? Finally, I want to thank both the Seaboard Foods Vet Services team and the UMN Swine group, especially Mariana and Caesar. They were instrumental in analyzing this data so we as a system can determine key action items. With that, I welcome any questions at this time.
Thank you very much, Donna, for your presentation. Very interesting. Certainly, you're making a very good point about having to shift our biosecurity practices and start including or doing more in the grow finish side of things. So thank you for that. We certainly need to be more aggressive at implementing biosecurity in growing pigs. So the next presentation for today, before we move to the group discussion, it's by Dr. Gustavo Machado. Dr. Machado is an assistant professor at North Carolina State University. Prior to that, Dr. Machado did a postdoc at the University of Minnesota, where I get the chance to know him. So it's very good to see you, Gustavo, again today. So his research interest is in traditional and novel epidemiological tools to investigate the spread of infectious diseases, including tools such as machine learning approaches that includes random tests or random forest tests. But his interest is in applying those methodologies to animal and human health. So today he will talk about how some of these approaches can be used to forecast PRRS based on the biosecurity risk. So with that, Gustavo, thank you for joining us.
All right. First of all, thanks for the invitation for this presentation. My name is Gustavo. I'm at NC State at vet school. I'm also a fellow at Geospatial Analytics department and campus. I'm putting here my website. You can find more information about our work in this website. So today I'm going to present to you a work that has been developed in the last 2 years in collaboration with colleagues from Iowa State. And the title is on how can we use and which biosecurity features can we use to anticipate and predict porous breaks at the farm level. So we're moving from benchmark at the system level to the farm level. So I'm going to give you an overview on that. First of all, I want to acknowledge my lab team members that have been pivotal not only to this project, but to all the other projects that we have in the lab currently. So without their help, we'll not be able to get to this point. So I'm thankful for having them in my group. So to start with, if we look into an infected site with pores, there is quite a lot of things that we don't measure, or metrics that we don't measure in the normal events that we are monitoring a farm. So there's a lot of unmeasured leaks that makes a farm to become infected. So we're not going to be able to toggle all of these features, but there are a few things that we already understand that are major in the risk for introduction of these kind of viruses. So one, of course, is vehicles and equipment that are shared or introduced to the site that facilitate the introduction of not only of pores, but other viruses and bacteria. We also know the importance of biosecurity entry and exit procedures. We all try to do what's supposed to be done on those regards. Now, so the other components we also learn it is about the moving infected animals into a site and all the biosecurity that are also related to the transportation that normally is neglected. So there's a lot of things here that either can keep a farm infected or can even facilitate a rebreak when farms trying to become stable. Then the question comes to about what's the difference and between a farm that is still susceptible or still negative compared to a farm that already broke. So normally the question is what I did wrong, or what are the problems that are actually allowing this virus to come into my sites. That's where we are trying to approach on this project and trying to provide you with some north where we want to focus at the beginning. If you don't know where to start, try to enhance your biosecurity features. So what we want to do with this project, and we've done already one round of data, is identify and quantify how much the current features, the current biosecurity practices are actually reducing these forces of transmission, either to the virus to escape an infected site or the forces that would facilitate a virus to enter a susceptible farm. So we want to figure out that. Now, so we want to give you a perspective of what you done last year, or what did you improve in your biosecurity last year, and how that either reduced or increased your chances of having a new break. And we want to do that quite rapid and make it accessible to the general public, which is not only the big companies, but also the smallholders that per se has breeding sites. So how this project can help you actually think about your improvements. So question that comes from the field is, for example, how similar or dissimilar my breeding sites are among my current sites, and how that play a role on one breaking, another one not breaking. And then also, what is the specific biosecurity features then that indeed are having a greater impact on my rates of pores. And then often some sites already did these changes, others are thinking about changing the dead pickups. Compare that with composting and incineration. By following your risk based on those changes, participating in this project would give you a sense of how much that actually is impacting your risk, either reducing or increasing. And just a note here to the participants in this project, if you're seeing that disposal coming up as important to your specific farms. In the next round of the report, have more clues about that. We are working on that more directly. So this whole goal is what I tried to explain in the beginning, is which biosecurity practice has actually impacted your birth rates in the past season. We are collecting the data from the past to see what you're gonna experience in future. So we started the project collecting first round of data in Iowa and North Carolina. We ran a bunch of models on these. I'm gonna explain a bit on it, but the ultimate goal is what I'm showing down in this plot here, which is basically an example. In the y-axis is your chances of having a break. In the x-axis is the feature that we are measuring, in this case, frequency of weaning. Expect that your chance of breaking, if you're cleaning that site very often, gonna reduce. However, with COVID and other things, you might not be able to do the same schedule, might not be able to wean the same amount weekly. So what we're able to show is how much those changes actually reduce your chance of reducing the risk. So if this become more flat, it means you need to do much more harder work to actually get the same reduction on the risk. So this is an example. Yeah. On phase 2, we are building this dashboard where instead of you sending a spreadsheet with data, you're going to be able to punch your own data into this. You're going to become an app as well in the phone, so you can do that quickly. You want to save as much time as you can. And two main results that we get here, and you receive this as soon as you click submit, is your probability of seeing a break based on what you've done until you send the data, so it's retrospective. An example here, I'm going to look closer to this soon. In the y-axis, you have your prediction of having break, so from 0 to 1, and on your x-axis, you see the number of outbreaks that farm has in the past. We're looking at 3 years back. And then the points are the farms, so we do a direct benchmark between your farms in your company, but also among all the farms that are participating in this project. And then the second result is it's very cool that you can actually have a sense on directionality of what you're actually doing in your site, so and what that's actually influencing your farm to continue to be positive or is actually bringing your chances down. Yeah, this is not a causation study, but it gives you an indication of what is actually influencing your risk to be higher or to be lower. So in this case, the larger the bar size, the larger the chances of this farm to continue to be positive, so to the right side of the axis. So this is the frequency of rendering. It was quite large for this site. And what is also cool to note is that the bars to the negative side, since this is a positive farm, are things that are helping you to reduce a bit your risk of having a break. In this case, is a multiplication this side, so that actually is pushing your risk a little bit lower. So in general terms, we do the work in this site, we collect information, we do our analysis in the background. I'm going to explain a bit. We store the data, we protect the data against this is not shared with anybody, it stays in the server. We do the analysis, and then the participants get a report, very detailed and a simple report. So it depends how deep you wanna go. We monitor your changes over the time. If you continue to participate, you can see how your change actually impacted your risk, which is the 3 here, the probability of having a new case. And we are working the benchmark to describe the farms that are in the lower category of the risk and the higher category of the risk. I'm going to show you the examples, but this is the whole summary, okay? So what we want is to see something like this. So this is an example farm where the changes were made in regard to filters and changing that pickup. We collect 3 samples here, basically on season, off season. So we don't want to collect so often, but as after you made the change, you expect to see an impact in the next season. We are not claiming that those are the only 2 changes that actually brought your risk down, but they had a very good influence because those are the ones that you recorded and you've done them. So Again, the y-axis is your risk, so your predicted risk from 0 to 1. Y-axis is the number of breaks. Each point here is a farm in this example, and the square one is the one that we are monitoring this time. So you can see we are bringing it down. We're gonna collect again to see if that's gonna actually reduce more for the next collection. We do 2 collections a year, okay? One during first season, one after we close the season. So a gentle introduction of what we run in the background. And this is a machine learning AI approach where we take 80% of the data in the database, and this is increasing. We have 350 breeding sites now. The more data we have, this becomes better. So we need to keep running these models in the background to get a better result, and that is because we are training an algorithm to understand what's going on in the data. So we take 80% of the data. You can imagine that we have a box of positive and negative farms. And with the biosecurity features, we're trying to split these into nodes. We're trying to separate the positive from the negatives. And we are trying to find out which biosecurity practice is actually doing that. In this case, an example, the annual turnover is splitting that more positive and negative to each of these boxes. But as you see, the nodes are not pure. They still have some mix between positive and negative. So we continue and we find the other variable that can split again. And we do that until we reach the end of these 3. And when we have a pure node or near to pure node, depending on the tuning that we are using, not to get much in detail, we stop making these decisions, and then we can create a rank of variables that are more important for the classification, in this case, of a positive farm. We run that 1,000 times, and then at the end, we average this together, and then we can get a rank of features that are more relevant for classifying a farm positive. We test these against 20% of the data that we keep some farms that the machine never saw. So we are fair in our testing. So this should be done in most of the training testing approaches. So we know that we have a positive or a negative farm and a positive farm, but we blind that to the machine and we run this through the classification, and we run multiple times, and then we see how many times actually this machine, they understood the pattern of the data, could actually divide and put them positive and negative on the right side. So if the positive is going to the right box more often, we run this 100 times, then our sensitivity is better. Yeah, and then we measure regular things such as accuracy, sensitivity, specificity, AUC, and then we get an estimation how good this model is actually performing. Bigger picture, what we basically do here, this is the world. We have the farms, we have landscape, we have things going on. We are collecting the data, putting in a data format. We are running our machine learning here. We are understanding what's going on in the data. It has been used a lot. Amazon, all big companies are using to actually sell us more products. But we are trying to interpret here basically the risk or the probability of having a new break. And then at the end, we need to communicate this back to us. So which are our public, which are basically the vets. So previously we did this study was done with the same group where we look at a longer set of questions or on a survey that was going on for a long time to try to see if we can simplify that and if we still have the same or increased prediction based on less features, so we can achieve our goal of making these more popular and more achievable and more easy to be used by other holders too, small farms and not only big. And also the big systems are very, very busy, so we need to make something that is still informative, is still good, but needs to be quickly. I'm not gonna get too much in detail. You're gonna read, if you're interested, you can read this paper. It has all the methodology that we run at the first run here. Basically, we divide the data as I explained. We run a bunch of different machine learning approaches. We select the best one based on the performance. And then we reduce, instead of 100 features, we reduce this to 40 based on the capability of predicting a good amount of the data. As we know, it performed well. we developed a methodology here that was able to split basically based on accuracy and other metrics, the variables down here that are not informing very well our decision of finding a positive or negative farm to the ones that are very, very important. So based on these and based on other methodology, we reduce the number of features. And then what we get, as I explained in the slide before, we are running these trees for a long time, and then we get an average of the features that are splitting better the data. And that's what we're seeing here. We're seeing a rank of those predictors. Another comment here, this is an order that would change with time because we are adding more farms to the data, and that's good, because then basically we are learning exactly what's going on in the field, and this is going to be updated as often as we add more farms, just because the splits in our tree are going to change because now we have different combination of farms in the database. So this needs to be up to date. That's why we run this every 3 months. We update this. Over here, you see the frequency of activities were very relevant. Now we include more farms, and I'm going to show you that basically this changed a bit. So the turnover it came up to be more relevant for the pool of farms that we have in the database right now. So this, you want to revisit this every time you receive a report if you're participating. General results of phase 2 that we are entering now, which is collecting the sites that already participate in the first phase. We are also accepting new farms. There's no restriction when you can join anytime. I'm going to put the contact information at the end of the presentation. So as I mentioned, now we have more sites, and this is updated results. So we have at the top rank of features, we have the turnover, yearly turnover, the distance to the main road, and we have more features that are related to the demography of where that farm is. So you see that this is to give you a perspective of what is more relevant at this moment. Yeah. So this is an average for the total population. This is not for your specific site. I'm going to show you the results for specific sites. Then we also included a new way to analyze the importance of these more relevant features, such as I'm going to talk about the turnover here. How you read this plot, in the y-axis you have a center value which is 0.5, which you can read that if it's above 0.5 you're increasing your chances of seeing a break. If you're below 0.5 you're reducing your chance of seeing a break. So as you can notice here, if your turnover is above 50%, you reach more or less the max for this feature. You increase a bit. We don't have too many farms that have a lot of above 50%. So as we include more sites, this could change as well. Yeah, but if you're below 50, your chances are actually reducing to having a break. Yeah. The distance to the main road, you can also see as you move further, you reduced your risks. If you have more farms around your site, those things we cannot change much, but that's what's coming important in this round of the data. This can change if we run it again, just because we add more sites. Just to remember, the red line is the average of all the farms, and each line here is a farm. So when we provide reports back to you, you're gonna see your specific site. So you can see some of the farms are not very affected by the turnover because I have so many other features that are keeping the risk low. Okay, then this is what comes next, which is the benchmark products of the project. So we have a general benchmark at system level, and then we have an individual benchmark for the specific farm that is participating. So this is a general way that we show. So there is a plot with the same axis, and we divide these in low, mid, and high risk. We are still working on this, it's not done yet. But as you can see, you provide farms that are negative. So we are showing your negative farms here, your positive farms over here. And then you can directly compare the average of your performance of your farms and the risk across the other farms. And you can see the system here. I'm going to give an example. Their positive sites are actually in the mid size. They are not as on the top side as this other system. Okay, this is general, so you can right away see what's going on across other companies without disclaiming which company, which data is that. So, and then when we look into the individual benchmark, each point here is a farm, and then I'm labeling the farms from system 4. So you're going to see where your farms actually lay on. So I have negatives in 0, and then I have positives 1, 2, or 3 breaks. And then we want to see why those farms are basically either higher or lower risk. That's why we're going to go into right now. So I'm going to look into the positive, into the negatives. So we're going to look into one example of a high risk and 2 examples of low risk. So this is where it becomes interesting, because we can actually tease apart which specific features had a bigger role in position this farm either lower risk or higher risk. So in this case, this farm here, the I09 is -1. Everything that is to the right side of the plot is, in this case, is helping this farm to continue to be negative. So this farm, for example, has no neighbors. They don't mix. They don't share equipment that are infected with pores. Their turnover is 0.4. They have a lot of green around their sites. They also filter, I think they filter the air as well year round, so that's helping a lot. So there's a lot that is pushing this farm to continue to be negative. So very hard this farm to become infected. Not that it's impossible, but everything is indicating this farm going to remain negative for longer. On the other side, in the negative side, we see some things that are making this farm push it to become positive. So one that I can point here is number of people working, really 21, but since this farm is very large, it's very hard to change. But this farm, it doesn't change much, it's supposed to continue to be negative. Now, if I look into this one, which is high, is negative, but it's higher, you can see the split between the good things that are keeping this farm negative and the things that are pushing it to higher risk. So to the higher risk, the things that if you wanted to decide to make a decision on making improvements, you will look to this site. Yeah. So this premise is a commercial site. You cannot change that, but in this case, for example, you are mixing animals, the breeding animals when you hold the animals. So you're doing that. So those things you can fairly easily change, and that should impact your risk and bring this farm down. Now, the problem with this farm is that the farm has basically these other features are also influencing to push it to the higher risk. Yeah, but the neighborhood is very good. It's very far from the road. Has only one entry. Turnover is low, so this farm has a big chance to go down. Now, if I look one positive one, I can see this one, and I can see this farm is located in a dense area, a lot of pigs around, is a commercial site, never filtered the air. So there are a few things here, 2 entries, things that can be changed that could perhaps bring this risk down. And there is just a few things that are not adding to the bucket here of making this farm more risky, is that the neighborhood, for example, have some bore studs, so that should not be a leak of virus there. So you receive this result and we describe the impact of this. So, and then if you run again, if you send the data again, we would monitor the change of these bars if you decide to take an action on these features. Okay. Moving forward in development, PhD students working in improving the difference between the risk high, medium, low. We need to develop a method for that. Right now is arbitrary, that cutoff. We still need to do a benchmarking as well inside each farm for each company. That's not implemented yet. We also including more methods to increase our capability of predicting these risks. And next steps, and there are also PhD students working on, is develop the web application, also a mobile app that's going to be available. There is some requests from Canada and US that want to use. We're going to make it available. We're also running a pilot project in UK and in Japan, looking at that. and the usability of these outside the US. Big limitations here, we have not developed yet for downstream farms. It's become more important to look into the finisher and nurseries, as we know they're contributing for the collateral spread. We're gonna look into that in this year. We are also not including other features such as the impact of production and co-infection comorbidities. And there is other things that we are planning to add moving forward to increase our capability to make good predictions. And then finally, also PhD students working on our package. So we're gonna make all the codes and all the procedures that we run here available to the general public, open source, for free for everybody. We are including in the same package the capability of adding your genetics, your sequences, your co-infections. So we should increase our capability of predicting the risk. And also we're going to include a spatial component. So we're going to actually use the distance directly from where this farm is located based on their neighborhood. So this coming up is still private repository coming up at the end of the year. I thank you for the attention, for the time. Here's my email. You can contact us if you wanted to either add more farms to the project, or if you're a new company that wants to join and give it a go for a first round and see what you get in return. Here's my email. Again, you can visit our website to get more information about this project and other projects that we are currently running. And a big thank you for the Swine Health Information Center for providing the funding, and also NIFA, USA NIFA, for providing the 2-year funding for this project to move forward. So I thank you so much, and I'm open for questions. Thank you.
Again, I want to thank our speakers for joining us today. Thank you for being here on a Sunday. I also want to thank our conference participants. I hope you found these presentations very interesting and enlightening and helpful for you. And lastly, I want to thank the SDEC partners for helping us with many of the research we do. So with that, hopefully we'll see you in the sessions this afternoon and for the rest of the Lehman conference on Monday and Tuesday. Thank you.